Okay, we now do the question number 4 from this handout. Remember that at the beginning I told you there is two types of questions. One question is to find the area or probability. We have to use normal CDF function. But other type of question is to find x value or g square. We use in-norm function. Okay. Therefore, in the handout, remaining questions are either to find x value or g square on the line. Remember that if you have a normal graph like this graph, and we are looking for either x value here or g value. It depends what the question asking for. Alright, let's find the question of 4. That is about to find x or g. Let's see. Question number 4. Okay, obviously, find the g square. Okay, if we're looking for g value, remember that you're looking for any one of the value on this line. But the criteria here is find the z square whose area on the right is 0.10. Remember that 0.10 is 10%. Area on the right is 10%. In other words, area on the right is 0.10 is the same as like 10%. Therefore, the question is asking for what is this point here? Okay, what is this point? Where area on the right of this point is going to be 0.10. Obviously, we're going to find the points here. Okay, we're looking for this point here. Notice that this is the z line because see here g here. This is g square. And therefore, you're looking for a point here on this line where area on the right from this point under the curve is 0.10. In other words, this area is 10%. In other words, I want to tell you, this is same as saying find g alpha. Here alpha is, look at the symbols, the symbols here. Look in the alpha. Alpha is area to the right of g alpha. Therefore, this question alpha equals to pretty much 0.10 because alpha is the area to the right of the point g alpha. And this point here is called, this point here is called z alpha. Z alpha is 0.10. In other words, we are looking for z alpha point z 0.10. Okay, and notice that in the homework or in the quiz or test, you might actually find g alpha. And if you look at the alpha here, this is always area to the right of the point that we are looking for. Here we are looking for this point. Look at this dot here. We're looking for this dot, and the area on the right of this dot is 0.10. That's the given, right? And question actually what this point is going to be. Okay, all right. Now this area on the right of this point that we are looking for is 0.10. Therefore, this area on the left is 0.90 because total area is 1. You subtract 0.10 from 1, you get 0.90. Therefore, I should say left area here is 0.90. This 0.90 is left area. Okay, left area. But the right area here is 0.10. Okay, you notice that if you know the left area, you can find the right area, or if you know the right area, here you know the right area, you know the left area. Now, to find this point here, you use in-norm. That's why we mentioned before. Okay, if you look at the notes at the beginning, I told you to find the x value or g square. Here we're looking for g square. We use in-norm. Therefore, in-norm is the function to find x or g value. Okay, all right. What do you want to do in the calculator? How do you find in-norm? you have to do the same thing as you find normal CDR. Go to the calculator, find the second GRS, and you guys see number 3, that's the in nerve. Okay, the in nerve. Now, what number are you going to put here? You got to put 3 numbers. You got to put first left area from this point you are looking for. Left area is 0.10. Oh, sorry, this is the right area. Right area is left area is 0.90, comma. The mean is 0, comma. Standard deviation is 1. Again, one more time. Here, the area given in the question is 0.10, which is right area. But to find the Z-score using in nerve in the calculator, you must use left area. Left area is obviously 0.90 from this point that we are looking for. So I use 0.90 as the left area. Okay, and press enter, and you get 1.28. That's the value of Z-score. That Z-score. Okay, therefore this point here is 1.28. We use in nerve 0.90, which is left area, 0 and 1. Again, 0 is the mean, 1 is standard deviation. You get 1.28. Alright, that's the 1.28 value. That's how you find the Z-score. But notice that some of the calculator has a option, like you got to choose left area, right area, or middle area. There's an option for that. If you have a calculator like this one, you type exactly this way. But if you have a calculator asks you to choose the area right or left, it doesn't matter. You can choose 0.10 to the right, or you can choose 0.90 to the left. It's up to you. But here, if there is no option to choose left or right area, you must put left area in the calculator function. Okay, that's how you solve question number 4 to find the Z-score. Okay, question number 5. Alright, the question number 5 is finding percentile. Okay, and remember from chapter 3, what do you mean by percentile? Here, and the question asks you the variable x is normally distributed with the mean 50, mean is the 50, and the standard deviation 7. Find the 38th percentile. Okay, 38th percentile, what do you mean by that? And let me tell you about 38th percentile in general. What do you mean by that? 38th percentile is the x value, right, where the area on that value to the left is 0.38 or 30%. Therefore, if you look at the graph here, I make a graph here where the mean is 50 here in the middle. You can see that, and this is, if you look at the area, I make a shadow here, dotted area here. See the red one, red dotted. This area is pretty much 38% of the whole area, but this area is 0.38. Okay, therefore I'm using that 0.38 as a left area to find this point here. Okay, pretty much I'm looking for this value, this x value, where the area on the left of this x value that I'm looking for is 0.38. Therefore, we use basically 0.38 as a left area in in-nerve function. Therefore, in the calculator you type in-nerve and use this left area, 0.38 as a left area, and the mean is 50 because you say mean 50 here, right? And the standard deviation 7, is 7. Therefore, these three numbers together under in-nerve gives you the x value, which is 38 percentile. Let me put that in the calculator. We did exactly the same thing as before. What I'm going to do is I'm going to do second and VRS number 3, and in you put left area 0.38 Remember that this percentile is always representing the left area. What's the mean? 50. And what's the standard deviation? 7. See, and close it, and you enter. You get 47.86. Therefore, this area is going to be 47.86. Depends on the fraction. If you round it 2 decimal places, you round it as 47.86. Okay. Therefore, this point here, look at this point. This point value, which is x, is 47.86. Okay. This is the question number 5. Question number 6 we did. Question number 7. Okay. Question number 7 is also used in there. Okay. And notice that the type of the question, find the data value. Okay. Obviously, if the question find data value, this must be x value, because data values means x value. Notice the data values there. But since you are looking for data values, there's more than one value, therefore it's a value. In other words, you're looking for 2 values. Okay. And here's the thing. I draw the graph here because, and the question says that represent middle 50% of the area. In other words, find the data value that represent the middle 50%. In other words, if I make a normal curve, this is the line, data value line, and this is the mean, the peak is the mean, and this is 500 because of this mean 500, and this time deviation is 100. Okay, time deviation 100. So again, if you make a graph, it makes it easier. Okay, it makes it easier. Therefore, always make a graph to find either area or data value or z-score. Here I make a graph like this, and I put this middle area as 50%. Therefore, this area here represents 50%, which is separated by 2 x values. I put this as x1, this as x2. Therefore, between x1 and x2, there is 50% of the area located, right? In other words, the 50% of the area lies between x1 and x2 values. And the question is, hey, what are those x1 values and x2 values? That's the question, right? Therefore, I'm looking for x1 and x2. But notice that if you look for x values, you look for the area on the left from that value you are looking for. So my question is, to find the x1, what is the left area from x1? That's what I'm looking for. That's the main point. Therefore, x1 is here. What's the left area from x1? Okay, obviously 0.25, because total area is 100%, the middle area is 50%, the remaining area is 50%. Therefore, this must be what? 25% area? You say 25%? Obviously, because this is 50%. See, dotted area is 50%, and remaining area on the left of x1 and right of x2 is 50%. Therefore, each divided equally to 0.25. Okay. Therefore, to find the x1, what I did here is I use inner. To find the x1, I use inner 0.25. Why? Because look at the x1 here. On the area on the left of x1 is 0.25. Therefore, I use 0.25 as the left area. Therefore, this is 0.25 is left area from this x1 you see in the graph. Okay, and the mean is 500. The standard deviation is 100. And if you use the calculator, you get 432.55. Therefore, the value of x1 here, this point here, is 432.55 when you round it to 2 decimal places. Similarly, to find x2, what's the left area from x2? Watch here. This is the x2 here, okay? This is the x2 here. And if you look at the left area from x2, look at this whole area on the left of x2. How much is that? Look at this all area here. All area. Do you see the area? All area on the left of x2? How much? 50% and 25%. Altogether 75%. Therefore, from x2 to the left, area is 0.75. Therefore, I use 0.75 to find x2 as a left area. Because here, x2 inner, this is the left area from x2, comma 500, that's the mean, and the standard deviation. We put in the calculator, we get 567.45. Therefore, this point here, this x1 is here, 432.55, and the x2 here is 567.45. In other words, 50% area lies in between. I should say lies here. Okay, 50% area lies in between these two numbers. That's how you find this, the value of x and x2. Question number 8 is similar. That's the last question in the handout. But here, find the data value, not the data value. Here in the question number 8, you find the z square. Okay, z square. That represents the middle 80% of the data. Again, this is exactly similar to the question number 7, except you are looking for z square here. Therefore, I put this curve and put z1 and z2, and this is the z square. And that mean is 0. Remember that for z values, mean is always 0. In other words, for z square or for standard normal curve, z value is always 0. Okay. Now this area here is 80%, middle 80%. Okay. Let me color that again. This area here, you can see I'm coloring right now. You can see I'm coloring. That's what, 80%. As a decimal, this area is 0.80. Therefore, the middle area is 0.80, and the question is to find a z score that represents the middle 80%. Therefore, here I'm looking for what's this z1 and what's this z2, because find the z scores, you have multiple z value. Okay, therefore you're looking for z1 and looking for z2. All right, and if I ask you what's the area on the left of z1, that's what you need. Obviously, total area here is 80%, remaining is 20%. That must be 10% here area is. This is 10% in this way. Therefore, this is area is 0.10 on the from the left of z1, and this area is 0.10 on the right of z2. Therefore, how do you find z1? Again, same idea. Use inner. Therefore, to find a z1, use inner 0.10. Remember this, the left area from that z1 that I am looking for, comma 0, comma 1, it gives you minus 1.28. That's this point here. z1 is minus 1.28. Okay, to find the z2, use the same thing. How much area on the left from z2? Okay, look at this z2. This whole area here, 0.80 and 0.10 total is area on the left of z2. Therefore, altogether 0.90 is left area from g2. Therefore, if you use inner 0.90, which is left area from g2, comma 0, comma 1, we get 1.28 positive. Therefore, here this z1 is 1.28 negative, and this g2 is 1.28 positive. And that's what the question is asking for. Find z scores. So you're looking for two scores that represent middle 50%. Sorry, middle 80% in this question. Okay? Alright. I think that's pretty much all handout. I think you make a nice note watching this video. Okay. All right. So look, guys. Thank you for listening.